though the errors have non-constant variances or unequal variances, but they are known to be a multiplicative constant of a variable which is known to you. This is how we proceed ahead with understanding what. One second. So this is how we proceed ahead and to understand in the model where there is presence of heteroscedastic errors or not. So the test, which is what mostly as far as R command is used, we talked about BP test and White's test. They all are a test using regression procedures to detect the presence of heteroscedasticity. So, agar by these tests you come to detect the presence of heteroscedasticity in the model, how do you actually go about remedial measures for the same? तो एक तो हमने remedial measures, वो remedial measure नहीं है, but it's just a bypass that if you are not too concerned about your model in the small sample, that is you're only concerned about larger sample case, so you can go ahead and use the White's heteroscedasticity consistent standard errors. That is, you can simply run the OLS as usual, and instead of reporting the standard error of the OLS estimators using the usual method, what we generally do, we report the standard errors using the White's heteroscedasticity consistent standard error method. That is just one way. But prior to, when there was no such method to actually remedy for the problem of heteroscedasticity, another class of estimators were used which were more efficient than that of OLS estimators. Now these class of estimators are called as weighted least square estimator. In short form, they are also referred to as WLS. पहले इसका लॉजिक देख लेते हैं, फिर रन दिस कमांड ऑन R. WLS क्या है? OLS क्या करता है? OLS works on minimizing the squared sum of residuals. This process works, that is, OLS estimator gives you the minimum variance out of all the class of linear estimators. This process works fairly well if your errors are not heteroscedastic. But when errors are heteroscedastic, what it means is that now your errors do not have the same, equal variances for all the observations. So in this case, if you go ahead with OLS method of estimation, what happens is that all the errors are attached with equal weights. And this precisely poses a potential problem where the OLS estimators lose the property of being the efficient or minimum variance property. WLS क्या करता है? Assuming that unequal variances of the population, again you have to understand that this unequal error variance itself is unobserved because you do not get to observe the variance of the errors of the population. So again it runs behind an implicit assumption that unequal variance is a some multiplicative constant of the variable, either that variable is in the model. So if you have a model, let's say if you have a multiple linear regression model including two explanatory variables excluding constant, so you write y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus error term. Now let us say what you presume or what you assume is that variance of UI, let me just present my whiteboard, just give me a second. Variance of UI, that is your unequal variances, is some multiplicative constant of, let's say, explanatory variable x2. let us just, for the sake of simplicity, let us just assume that your variance of ui is proportional to the variable x2, meaning which that as x2 increases, the variability observed in the errors also increases. So this is an assumption. This is how you're able to remedy for the problem of heteroscedasticity using weighted least squares. So let us see how do we actually go about this. So एक चीज हमेशा याद रखिएगा that WLS method of remedial measures works only when the researcher is
Sir, are you
sure.
presenting? It's not
Yeah,
visible.
no,
It's not visible.
I'm not presenting yet. Yeah, can you see the screen now, all? Can you see the screen, all of you?
Yes, sir.
Yes,
Yes.
sir, it's visible now.
Okay, all right, all right. Just give me a second. Okay, so let me write what I have been saying. So suppose your original PRF is and let us assume that variance of UI is, let's say, sigma squared times x2i. What it says that your unequal variance, if you write it as sigma I square, is proportional to this variable x2. This is what we assume. And this is a multiplicative constant, that your sigma square multiplied by this x2i. So what we do, how do we actually go about in this case then? So if I run a usual OLS in this case under the presence of heteroscedasticity, we have discussed about the possible consequences of it. That is, your OLS estimators, it will no longer be efficient estimator, and also the estimated standard errors will be biased so that your usual test of significance stands invalidated. So these are the possible consequences. So एक तो method है कि हम normal OLS run करें and we use the heteroscedastic consistent covariance variance matrix for the OLS estimators. And then, since this is valid only for the last sample or asymptotically, then we can proceed ahead with the usual test of significance, which are valid in the large samples. But if heteroscedasticity is a serious concern for you as far as the model is concerned, we try to remedy the problem. So one very common sense method is you transform the variables, and mostly the transformation works in the form of taking logarithm of the variables. रीजनिंग ये है कि log क्या करता है, log एक otherwise large numbers को it shrinks the number. So if there is any visible systematic pattern of residuals with any of the variables, by shrinking the number, by shrinking the variable, what it does, it diminishes that well-established pattern, and somehow you are able to remedy for the problem of heteroscedasticity. But this transformation not always works. That's where you have the method of weighted least square, where what we do is, instead of minimizing the sum of square residuals, what we do is we minimize the sum of weighted squared residuals. So in this case, for example, we have taken that variance of ui is some constant proportion of the variable x2i. So what we do now, we divide the entire original OLS by the square root of this x2i. You'll see the reason why we divide it by square root. So what you write here is yi x2i is equal to beta naught upon x2i plus beta 1 plus ui upon x2i. And then we simply run the OLS. एक चीज हमेशा याद रखिएगा कि अगर आपका original model contains an intercept term, and if you're dividing the original model by any weight, then your the model that you're using or running using the weights will not contain an intercept term. All right. So now let us look at this term, which is your ui upon under root of x2I. Let us call this as vi. Now, if I talk about variance of vi, so variance of vi will be variance of ui divided by under root xi ka whole square, because this is a known constant. So we know that variance of ax is equal to a square variance of x, and that's why it gets squared. So variance of ui, we just saw it is sigma square times x2i. Now this under root x2i ka whole square will be x2i. So this gets cancelled, and that's how the new variance for the error term, this is that is weighted error term, you get as sigma square, which is a constant. And this is the method of WLS, that is a weighted least square. But always remember that this method will only work when you exactly know that the weight by which you are trying to normalize the residuals is a known multiplicative constant of some variables in the model. There are other variants to this, whereas if you exactly, or you're unsure of which variable is responsible for influencing the error variances, so instead of using weights as one of the explanatory variables, what is done is the fitted values of y is used as weight. Such methods are called as generalized or feasible generalized least square. So WLS, that is weighted least square, is just one variant, one possible variant of a method or method of estimation called generalized least square. But before we move to that, let us try and run a very simple command on R, where we'll try to understand how do we exactly run a weighted least square regression.
Sir,
इसमें बहुत सारे वेरिएंट है. Suppose in this case, in this case, if you assume that it is sigma square x2i ka whole square, that is, it is proportional to the squared values of the explanatory variable x2. Same case आप divide करते x2i से, because जब आप variance फाइनल एरर टर्म का निकालोगे तो जो कांस्टेंट टर्म है वो स्क्वायर्ड हो जाएगा. इसलिए जो भी आप प्रोपोर्शनैलिटी मानते हो उसका एक पावर लेस से आप डिवाइड करते हो. So always remember this point. So if you assume if you would have assumed here that variance of ui is sigma square times x2i ka whole square, instead of dividing the whole expression by under root of x2i, we would have divided it by x2i only, because then you have ui upon x2i. 1 upon x2i ka square will be in the denominator. In the numerator, you will have x2i ka square. That will get cancelled out each other. So this is precisely the method of weighted least square, where you minimize the weighted sum of squared residuals. You can see here that now what is being minimized is this vi and not ui. And vi is what? Vi is ui upon under root of x2i. That is, each of the observation is getting or has been assigned a weight. So larger error variances have been assigned a lesser weight, and lesser error variances have been assigned a greater weight. This is how this weighted least square works. Now I'll request all of you to switch to R Studio, that is like open R Studio on your possible laptop. Yeah.
लाइक जो इसमें ट्रांसफॉर्मेशन लॉग का करते हैं सर, कोई भी वेरिएबल में, तो सर उसका इंटरप्रिटेशन चेंज हो जाता है.
या लॉग क्या करता है? जब यू सी व्हेन यू राइट y, if you simply have this, तो यहां पे बीटा वन का इंटरप्रिटेशन क्या है? डेल वाई एक ही है, तो लेट मी जस्ट यूज dy. dy upon dx That's how this beta 1 is. That is for a given unit change in x, how y changes. So dy will be your beta 1 times dx. Now instead of y, what you do is you have log of y, or let's say log of x. So either you take semi-log or log equation. So just for the sake of simplicity, let me write is log of x. Now this beta 1 क्या बोलता है मेरे को? This beta 1 is now d of log y upon d of log x. Now d of log y is what? 1 upon y dy. d of log x is 1 upon x dx. So if you just थोड़ा सा आप algebraically इसको manipulate करोगे, so what you notice is that log, that is taking the first differential of log, gives you the proportionate rate of change. You see, what is this? dy upon y is what? This is the original variable, and this dy is nothing but y2 minus y1. That is change in y upon y. So that's why when you have logarithm, it gives you the proportionate rate of change. अब जब सेमाई लॉग मॉडल रहेगा तो उसमें एक वेरिएबल का प्रोपोर्शनेट रेट ऑफ चेंज होगा, एक वेरिएबल का एब्सोल्यूट चेंज होता है. बट जब दोनों लॉग अप्लाई करोगे तो इन दैट केस दिस बीटा 1 इज कॉल्ड एज कांस्टेंट इलास्टिसिटी. Because now you see this beta 1, which is expressed as dy upon y upon dx upon x, is nothing but elasticity of y with respect to x. कैसे हम elasticity define करते हैं? How do you write price elasticity of demand? How do you write price elasticity of demand, guys?
minus dq by dp into p by q.
So you simply write dq upon q upon dp by p, right?
हाँ yes sir.
Right? ये क्या है elasticity आपका? Elasticity is nothing but ratio of two proportionate changes. Is this clear? And that's why the coefficient in the log model is also called as constant elasticity coefficients. ठीक है. सो जब आप लॉग लगाते हो किसी वेरिएबल में, तब आप उसका जब रेट ऑफ चेंज की बात करते हो, देन यू आर टॉकिंग अबाउट प्रोपोर्शनेट रेट ऑफ चेंज रादर देन एब्सोल्यूट चेंज. इज दिस फाइन?
हाँ सर, थैंक यू सर.
Yeah. All right. I request you to open our studio on your laptop or iPad, whichever form you're using. And let me just present my screen. All right. Can you all see my R Studio on the screen?
Yes, sir.
Yes, sir.
All right. So I want you to load the data package or the data set, not data package, K401K subs from the package Woolrich. Please do that. So I want you to load data K401K subs. This is again an example from Woolrich chapter number 8. So just this is your data set or data matrix. Now I want you to run a regression. Just listen to this very carefully. I want you to run a regression where you regress net total financial assets, which is your this variable, NET on the income, on this mail variable, on this E401k pension plan variable, and the squared value of age. But instead of running the regression on age itself, the example uses running regression from age minus 25. That is, why it does is because the minimum age in this data set is 25. So they have transformed the entire age variable around 25. So instead of using age as it is, you use age minus 25 squared in the regression formula. So please do that. You have to run a regression of net total financial assets on E401k, income, male, age, but transformed age, and for single individual, this F size is your family size. So single individual will correspond to the subset of F size having a value 1. So please do that. And once you're done, please let me know. Please continue doing. I'm also doing here, but try एक बार खुद से करने का. मुझे स्क्वायर टर्म्स डालना है, तो what I do is I write I in front of the variable जिसके लिए मुझे स्क्वायर्ड और पॉलिनोमियल टर्म्स डालने हैं. So I have to use age minus 25 इसका स्क्वायर, then I have to use the data set is K401k subs, but I only have to take the family size corresponding value 1. So हमने कल देखा था, we write subset equals family size F size equals 1. So some problem, I guess. Oh, close होना चाहिए. So have you all got this regression? Guys, are you done? Have you all got this regression?
Sir, I'm getting different intercepts.
No, sir. Can you just wait for a second?
या इंटरसेप्ट अलग आ रहा है, बाकी सब सेम है.
Sir, is that E401K?
Yeah.
Okay, sir.
Sir, all the coefficients I'm getting are different actually. I don't know why.
जस्ट चेक कि आपने जो एज -25 का स्क्वायर लिखा है वो सही से आया है कि नहीं, बिकॉज यू कैन सी इन दिस केस I had to insert a bracket because otherwise it just takes age -25 as the only variable you see here. So that is the wrong way. So I have just corrected it here. So just check.
Okay, so now got it after the second bracket.
Yeah.
But sir, why did we give it and why are we giving that I?
Because I have to run the regression on not age -25 but उसके squared values पे. So in order to have polynomial terms in the regression formula, either you can use the function, that is you can also use, let me write it here. You can also use अगर आपको I से दिक्कत हो रहा है, you can use poly age -25. So this tells you the variable and कितना, तो raw is equal to 2. That is, I have to take the squared value. Raw is equal to 3 करोगे, it will give you the third function. So instead of doing this, what we simply do is we write the capital I, then the variable which I'm talking about. In this case, the variable is this. And इसका कौन सा term चाहिए मुझे? इसका चाहिए square term. So it simply is this term. Is this clear?
Okay, sir, but still a doubt. But why are we taking age -25 as the variable? Why not simply age?
This is the example from the textbook. Precisely because the minimum age is 25, and what has been generally observed in the data set that income tends to increase more positively when the person is above the age 25. So instead of having the ages in greater number, what they've done is they've transformed all the relative age with respect to 25. So अब base 0 नहीं है, base 25 है. That is nothing, और कोई changes नहीं है इसमें.
Okay,
So if the age is below 25, so obviously the income will fall. That means.
Correct. Yeah. I have used the example, I think 8.4 है या 8.6, I don't know. Just एक बार check कर लेना, but ये Bullrich का ही example है. Is this clear?
I was a little silly doubt, but so what about the subset function, sir? Can you just explain on
अरे
that?
silly doubt कुछ नहीं होता है. Please don't utter things like this at all. मैंने कभी ऐसा किसी को feel नहीं करा है. Subset is when family size is equal to 1. That is, you have to run a regression. That is, you have to talk about, देखो इस regression का मतलब समझ लो, तुम्हें अपने आप चीजें समझ में आ जाएगी. I have to talk about net total financial assets of individuals, single individual who are above age 25. So I ran a regression where I say that net total financial asset of individuals depend on the income that he or she that he earns, because I'm only regressing on male, whether he has E401K pension plan or not. Then I understand that net total financial assets increase for individuals above the age 25, but it increases in a quadratic fashion. That's why I have a polynomial term over here. And I'm only talking about single individual. That's why I have used here subset is equal to f size is equal to 2. If you want to talk about single individuals and having family size 2, तो यहाँ पे f size equals c1 2 करते हैं. So this is how you generally create that subset. Is this clear?
Yes, sir.
ठीक है. और please never use this term at all again. It's a request.
Sure,
All
sir.
right. हाँ जी.
वन मोर थिंग, लाइक अभी जो हम सबसेट इज इक्वल टू 1 कर रहे हैं, दैट्स मीन जो भी फैमिली साइज इनका 1 है, या फिर हर एक पूरे फैमिली साइज में सिर्फ 1 को लेना है? सब
सिर्फ हमने फैमिली साइज 1 को लिया है, 1 वाले को काउंट किया है.
ओके. सो सर, जब हम वो एज बढ़ती है तो फैमिली साइज ऑब्वियसली वो इंक्रीज होगा ना, राइट सर? तो ऐसा नहीं हुआ कि हम मॉडल में वो जो फैमिली साइज जो इंक्रीज हो रहा है उसको हम एक्सक्लूड कर देंगे?
इट डिपेंड्स. लाइक यहाँ पे मैंने एक रिग्रेशन रन किया, जो ये जरूरी नहीं कि एज बढ़ेगा तो फैमिली साइज इंक्रीज होगा. इज इट नेसेसरी?
बट सर एक होने मतलब एक का प्रोबेबिलिटी तो कम होगा सर. आई मीन
हाउ डज इट मैटर? इट्स अ डेटा सेट. जरूरी कि सब मतलब फैमिली साइज
जस्ट मॉडल का बात कर रहा था.
हाँ,
मॉडल में कोई इशू नहीं होगा तो ठीक है.
कम अगेन.
अगर इससे मॉडल में कोई इशू नहीं हुआ तो ठीक है, मतलब लाइक
see, the data set is there where your family size only, that is they are single individuals who are above age 25. उनका मुझे net total financial asset निकालना है. I'm not going to social and psychological thing whether he or she should get married or not. So that is altogether different aspect. ठीक है.
सर, I'm not talking about that. Okay, thank you.
सो इस डेटा सेट में मेरे पास है इनफ डेटा पॉइंट्स जो कि सिंगल इंडिविजुअल्स हैं इवन अबव द एज ऑफ 25. चलेगा? All right. So now if you let's say run whether you run this model for a heteroscedastic test. So please run a Bruce-Pagan test for the same. How do we do this? How will we run this, dear? You have to run a command where you test the model for heteroscedasticity. What should I do then? Yeah.
So we take the residual values and then run our regression on the residual values.
Okay. और हम simply direct command BP test REG भी कर सकते हैं.
Yes, sir, that also.
Right. So it somehow suggests that your model suffers from heteroscedasticity, right? Because the p-value of this BP statistic is very, very low. So what I've simply done, I have simply run a Bruce-Pagan test on the regression variable REG, which is how I have stored my variable, and the p-value comes out very, very low, which suggests that there is evidence of heteroscedasticity in the model. So आप ही की तरह कोई रिसर्चर है, वो बोलता है कि चलो हेटेरोस्केडास्टिसिटी है. मैं क्या नोटिस करता हूं कि जो नेट टोटल जो वेरिएबिलिटी है एरर्स का इन द मॉडल, इट इंक्रीजेस proportional to the variable income, and it is proportional to the squared of the income variable. That is what the researcher assumes is that the error term or variance of UI is equal to sigma squared times income ka square. So now in order to remove the problem of heteroscedasticity, the method that we'll use will be called as weighted least square method or WLS. So let us see how do we actually run this regression. So So let me call it as WLS REG. Again, I'll run the same model. बहुत सिंपल है ये, आइदर आप मैनुअली कर सकते हो और देयर इज वेरी सिंपल कमांड जहां पे मुझे सिंपली क्या करना है that before this data set, that is now you're running a weighted least square regression. So weighted अगर मैं रन कर रहा हूँ, it means मुझे weight define करना होगा. So I write it here as weight is equal to 1 upon income. अगर आप और अगर रिसर्चर अज्यूम करता that it is proportional to the income variable, so यहाँ पे होता weight is equal to 1 upon square root income. So accordingly आप जैसे weights define करोगे वैसे आपका WLS, that is weighted least square regression आएगा. Yeah. So now if you simply run the WLS REG, you will get, or let me say summary. Yeah, so this is the final value that we get. Again, अगर मुझे ये simply एक coefficients आ गया, that is instead of summary we could also have used COEF test, which also would have given in the same manner. But एक चीज यहाँ पे आपको clear होना चाहिए that even though you used that is weighted least square method here in this case, your estimate of variances might be biased because still the formula that ये weighted least square to run on the assumption that the error term moves proportionately as square of the income. So still there is some assumption behind it. So apart from this usual test of coefficients, as a researcher, you should also run the WLS, that is weighted least square regression, combined with heteroscedastic consistent covariance variance matrix of the estimators. So again, I don't have to do anything. I'll simply call COEF test function. I'll have WLS REG, जैसे मैं कल किया था, and variance covariance that I use is HCCM. Let's say this. Should simply write it HCCM. Yeah, so I had to call the car package because this HCCM command is in the car package. So you can see here for yourself that the standard error in the heteroscedastic consistent, that is corrected standard error, will be different to that of the standard error which you obtain in the WLS REG. So why I would request you to run in the presence of heteroscedastic model, use the heteroscedastic consistent standard error, because in that case more or less the t-test, अब यहाँ पे इस particular example में बहुत ज़्यादा difference नहीं पड़ा है, because you can see almost all these test statistics जो उसमें significant है, in the same manner यहाँ पे भी significant है. However, this slight change in the E401K plan, that is now as per the consistent standard error, the E401K coefficient is statistically significant even at very low level. But you can see for yourself that it is statistically significant at 1%. That is here the 2 star is referred for 0.001. So there's this slight change, but I always encourage you to run the regression using HCCM and base your results on the basis of, or that is test your significance hypothesis on the basis of corrected standard error rather than uncorrected standard error in the presence of heteroscedasticity. So are you
So-
all still go on.
Why have we done this COF test after doing the weighted least square?
Because weighted least square still uses the variance covariance matrix of the homoscedastic error terms. बिकॉज वेटेड लीस्ट स्क्वायर में आपने क्या किया, आपने एक वेट डिफाइन कर दिया. सो जो स्टैंडर्ड एरर आप जो स्टैंडर्ड एरर दैट यू स्टिल गेट इन द वेटेड लीस्ट स्क्वायर रिग्रेशन, it will still be from the uncorrected matrix. So that's why we simply use HCCM to check whether the standard error that we get in the WLS is right or not. So mostly जो HCCM है, in this case what happens is that you do not assume for homoscedasticity at all. I'll repeat this point again and again. कल हमने क्या देखा that जो variance covariance of B है वो under the presence of heteroscedasticity changes drastically. So जो भी WLS का test था, that is based or it assumes the presence of homoscedastic error term. And why I'm saying this, because when you divide the errors by the weights, you make the errors homoscedastic, isn't it? So in that case, even if you use WLS, I encourage you to always run a test of coefficient using the corrected standard error matrices. That is your White's heteroscedastic consistent standard error. ठीक है?
Yes.
Sir, I have one doubt.
हाँ जी.
In this WLS model that we just created,
हाँ
even
जी.
if we run a BP test on this model, why is it coming to be a very low value? Like we just removed the problem of heteroscedasticity, right? If we just run a BP test WLS model, that's REG2, I think, in your case.
Correct.
If you just check, the p-value is also very low here, but we just removed the problem of heteroscedasticity, right? Then why is it happening?
You are saying that if you run a BP test on WLS REG, right?
Yes. Sir.
So,
Sir, it's exactly the same value that we were getting before.
Yes, sir. So like saying it's not removed. Like if we go by the test, it's saying it's not removed since the p-value is very low.
So that's what I'm saying. So what it basically says that the weight that you used is not a correct weight. So that's why WLS in this case does not work here. ये एग्जाम्पल है टू अंडरस्टैंड कि WLS आप कैसे रन करोगे. इन दिस पर्टिकुलर केस वेट्स जो भी आपने अज्यूम किया है दैट हैज नॉट वर्क. इन व्हाट इट मींस इज that your error variances are not proportional to the squared value of income. It means you must go ahead with certain other assumptions.
So how can we identify what's the actual variable that the variance is related to? That what should be the actual weight?
And precisely for this, what we use is called your generalized least square estimator. I'm coming to this point only. What it means is, you see, WLS को यूज करने के लिए, दैट इज वेटेड लीस्ट स्क्वायर को यूज करने के लिए, ये जो अजम्पशन है कि वेरिएंस जो है आपका, वेरिएंस ऑफ द एरर टर्म इज प्रोपोर्शनल टू अ रिग्रेसर, इज वेरी हार्ड टू जस्टिफाई. यू एग्जैक्टली डू नॉट नो व्हिच वेरिएबल, और क्योंकि ये सारा अजम्पशन के ऊपर बेस्ड है. अभी आपने जस्ट एग्जांपल में देखा दैट दिस डज नॉट चेंज एनीथिंग इन आवर रिग्रेशन. इट मींस इवन इफ or your assumption that is your error variance is proportional to the regressor income is not at all correct. And typically we do not know this variance function because it is unobserved and have to estimate it. So basically, instead of this weighted least square method, what we now will try and understand will be called as feasible generalized least square estimator. What it does is it replaces this known variance function with an estimated one, and let us see how exactly it is being done. So idea क्या है यहाँ पे कि मुझे weights use करना है, that is, but weight क्या होना चाहिए वो I do not know. So there is this method in which what we do is we go ahead with simply running the linear regression as it is. That is, we run the OLS of the original model. In this case, what I'm talking about here is, so one second. So we'll run this OLS model as it is. Then we obtain the residuals from this regression equation. And we square the value of the obtained residuals from this original regression equation. And then we take logarithm of that squared residuals. And now in the second stage, what we do is we run this regression. That is, we run the regression keeping log of squared residuals on the regressors used in the original model. Either I can go like this, or I can run the regression keeping dependent variable as log of squared residuals against fitted values of this regression equation. That is the fitted value and the polynomial terms of fitted values. और जो estimated value आएगा आपका log of u hat का square, that is what you get as estimated log of u square का hat, inverse of that squared residuals can be treated as weights in WLS estimation. So let us proceed ahead what I have talked about. I'll just outline the steps in the source function. So what I've said here is you run the OLS as it is. Okay. उसके बाद you obtain the residuals, you square, that is you take log of squared residuals and regress this against all the explanatory variables in the model. So either you can do this or you can regress this log of squared residuals against the fitted values जो हमने white test में किया था. अब जो आपका उसमें estimated log of u, that is जो आपका estimated value आएगा log of u hat का square का, उसका inverse can be treated as weight in the weighted least square regression. So please do this and just see if anything changes in this particular example. So what I'll do now here is, मुझे क्या चाहिए? मुझे चाहिए residual of REG. Yeah. So I got residual of REG. Next, what I have to do is I have to take logarithm of this squared value of residuals. So let me say that, u is the variable. So what I do is log of resid of REG पूरे का squared. Yeah, and yeah. फिर मैंने एक नया वेरिएबल बना लिया, that is my log of residual from the regression का squared. Now what I do, I have to run the regression. So what I'll do is, let us say it is R. So LM U against all the variables that I've used in the model. So let me just conquer variable. वेरिएबल्स है INC मेल E40 INC -20. INC mail E40 ये ना डेटा
So you didn't run the U wala code, I guess.
come
Sir,
again.
scroll up a little. I am getting different residual values. I just want to check.
1 second. Yeah. This is the residual. What I've done is
Sir, can you please scroll up more?
here.
So the install packages. I misspelled it.
Yeah.
Sir, वो first line, sir.
Sir, in the residuals, you are getting something 4,000 values and I'm getting 9,000 values. I'm not understanding why.
Come again. I didn't get you. What you're saying? Residuals 4,000.
You have got 4,000 values if you see the residuals, 4,000 something values, but I'm getting 9,000 something values.
Have you used the same regression results? It should not happen that way. Just check once, please. It is omitted certain entries as well. Just check the points if you're getting the same.
So it is also like, the last command that you have made us run. So it is giving that, it's giving an error that length is different.
I'm just checking that only. Just give me a second.
Sir, you didn't run this U command, if I'm not wrong. Maybe.
So there are two equations of LM. There are two equations of LM.
Sir, I'm getting an output of 11.23365 R value.
What? This R?
Yes, sir, 11.233.
1 second. What I've done is This regression.
So I've pasted my
One
command
second.
in the chat box.
1 second. 1 second.
Yes, sir.
Yeah, you get this.
No, sir, I was getting a single value.
You are getting a single value.
So I ran the earlier command which you wrote. Through that, I was getting a single value.
Okay. So just let me just paste it. Why it is not working here? Is it working in your it says variable is not same.
So can you just once copy paste my code that I've pasted in the chat box and then
Ah,
try?
I've done that. I've done this part here. Is it working in your system?
No, sir, I'm getting the same error.
Hannah?
Yes, sir, same
Yes,
error.
sir.
Same error, sir.
Sir, after this command, I've run R. I've written R and then I've again run the command.
No. What I'm saying is that it says variables differ, variables length differ. It means there's some problem.
Sir, ऊपर जो ये omitting वाला part दिखा रहा है, like what does that mean? That it is not calculating residual for that part, or like if it is not showing the entries for that
Sir,
part?
it was showing the same error in my also. The
It
length
has
is different.
omitted all those entries because you see it is max.print.
So basically, residuals are calculated, but it's not printed here. That's what you're
Yeah,
saying,
yeah,
right?
yeah.
But sir, I got some different residuals that I don't know why. I
You are
ran
getting,
that same model.
how can it be possible? How can you get different residues?
Sir, I also am getting the same error. There's different values. So after this error, I've run R again, and then I've got the single variable.
No. So instead of that, let me just do this point, which I've done here. So yeah, let me store this as it's a T. It's medium. So just to check जिसका different residuals आ रहा है, ये आपका first six कुछ values ऐसे आ रहा है? Just check.
Yes sir, these values are same, but the last like end में जो values आपको दिखा रहा था वो अलग आ रहा है. These
So
values are
just
same.
so just check by tail function if you are getting the same or not. Last values ये आ रहे हैं.
Yes, and now it's the same.
Yeah. Okay. All right. So, अब मुझे क्या करना है? I'll run a regression of log of ui square. So what I do is I have stored my residual of regression from for as t. Let me create a new variable where I take log of t. One second. Square. So it will give me log of residual square. Yeah, so now I've got log of residual square. What I do now, I run a regression of log of ui square against the fitted values from the regression. So what I do is I define a new variable where I get fitted values from original regression. So this will give me fitted value of regression, correct? Then I run a new regression where I'm running lm y against u plus I u square. Square is correct. Yeah. So if I do summary O now, yeah. So now if I get the fitted value from this O, and then I'll say weight at, I can define a new variable as weight, and that will be, let me say that W is 1 upon X. Now I'll run the same WLS REG as W. Let us see if it is works or not. Be करता, then we'll check. Oh,
So shouldn't we write weight equal to W since W is already equal to 1 by
oh,
X?
yeah. Correct, correct. I'm really sorry. Yeah, yeah, you're right. Should write it that way. Yeah, it should be W. Why it is saying it? Some problem I don't. Don't say. See something. It should be expected value, I guess. Yeah, it should be expected value instead of that. Yeah, now let me see if it works. Yeah, it should be expected value. अभी तक हम fitted values पे थे. Maybe that's why it is coming like that. Let me just check. So if I run weight is equal to W. Length coming out to be same. I don't really know what is happening here.
So I guess the problem lies in the residuals because the residuals value are some 3,000 something.
Again, residuals?
The number of residuals we are getting is 4,662 in your case.
No. I don't think you're right there. We just saw, I think, residuals. अभी हमने देखा था tail of residuals, I guess.
There's some 9,000 values.
So आपने X1 देखा था.
No. We just saw tail of residuals.
9275 values, I guess.
Tail of residuals also.
No, here only.
Yes, sir, 9275 values.
Residuals of tail, na?
Yes, sir. So tail X1 is your 92. If
Yeah. I don't know why it says it variable length differ. It's the
Sir,
same.
it was
only.
showing with respect to income initially, like if I'm not wrong, but I am not sure why that is happening.
Yes, sir, it is showing that income length differs.
But
Can we check the count of income observations if that is possible?
Because it's showing it's the same 97.5, yeah.
So it could. No, I was saying ki, is this data like it does not has any null values, right? If we can check those things and then maybe we'll figure out why there is a difference in length.
Okay, so just for the timing, what we'll do is we'll keep this portion on hold so that we don't miss out on other things. So is data set, while I just rework it after the class gets over, and then I'll send you. It works. So just to take the example, just जो भी हमने देखा. So instead of working on this particular data set, let us take this. We'll just try to see this GLS estimator works or not. Just so instead of this working on this data set, just load the data, which is an example 8.7 from your Woolridge book. So you have to. Otherwise, a lot of time will get wasted. Very wasted a lot. So load this data set, smoke, which is named as smoke. Just explore the data. So this is again the data set that we have. And then do this following step, run the normal OLS, check for the heteroscedasticity. After checking for the heteroscedasticity, define the weights by this log of squared residuals. And just see if this works here. If it works, then we'll proceed ahead. Just do this part.
So the regression on which variables?
You have to run a regression of cigarettes, that is your number of cigarettes, on, let's say, price of cigarettes. Income, let's take all this variable. Education, age squared, and restaurant restrictions. And instead of prices, let us take log of income and log of cigarette prices. So you have to run a regression of number of cigarettes on log of income, education, age squared, restaurant restrictions, and logarithm of cigarette price. So run a regression.
So can you repeat, please?
Yeah. Run a regression of number of cigarettes against age squared, log of income, log of income is L income, it is already given, so you can write that as well. Income, log of cigarette price,
And education?
Yeah. And restaurant restrictions.
So just to, sir, you have written log and you've written income.
Haji.
There are actually columns in the data set which are there as L income and L cigarettes.
You can take that as well. I don't think so.
All right, sir.
Yeah.
And sir, you had mentioned that if we are doing any mathematical operations, we should use that I symbol. Here we are not using it.
यहाँ पे age squared है ना नहीं?
अच्छा, but sir log के लिए?
Log के लिए it will be simple. See, polynomials करने के लिए we take this I.
ठीक है सर.
है ना? Yeah, then simply run, BP test. this R a low value BP test, it suggests then let us define a variable T, which is your residual. Let me write it as log of S equal R squared. So this is my log of residual R square. And now I have to run this regression on the variable that I have. So let me call it as R1 LM D on welcome. And again, data should be small. Yeah. This is R1, which I'll get the regression of log of squared residuals on the variables. अब जो weight है, that weight will be reciprocal of this expected values of fitted R1. So let me just define as F as fitted, or let me make it as expected. Sorry, not expect. Sorry, exponential values of this fit value of yeah. So let us define as this. Solution. No. Let's go inside R2. And see. Yeah. Now, if you simply run a BP test, it changes. Yeah, it changes now.
Yes, sir. Could you scroll up,
Sir,
please?
sir, I'm very sorry, but it's getting very difficult to understand why you're doing what you're doing at this point.
Which part? Just tell me. I'll start from there.
So this
No,
whole
sir. Sir, in general, sir, I know we found the residual, then we squared the residual. Then at R1, we are doing a regression of the same X on the squared residuals. Now, what are we doing in F? And I'm not understanding why are we doing it.
Were you there, Neil, when I discussed about कि weights कैसे decide करेंगे?
No, sir, I think I joined at like 10:10.
Correct. So that's why you're not getting it. So the reason is that weights, जो weighted least square method है, वो work करता है. That is, you assume your variance of error term to be proportional to one of the regressors.
Yes,
ठीक है?
sir.
So, but this again is an assumption which is very hard to justify. So the idea is that if you're not sure that on what values the variance of the error term depends, so in order to decide, in order to define what weights should be used in the WLS method, that's what we are doing now. So what we have done is, as usual, we ran a regression of this particular term. Then in order to get to the weights, the method is you simply run the OLS as it is, then you get the residuals from the original OLS equation, you square that residual, then you take logarithm of that squared residuals, that becomes your dependent variable.
Yes, sir.
Now you run that logarithm of squared residuals against all the explanatory variables in the model that you, in the original model that you have used. चलेगा?
Yes, sir. Yes, sir.
ठीक
Got
है?
till there.
हाँ, अब जो फिटेड वैल्यूज जो आएगा उस पर्टिकुलर रिग्रेशन का inverse, that is reciprocal of that fitted values, will give the weights in the WLS method. That is, जो variance of UI है, इस केस में जो आपका डिपेंडेंट वेरिएबल है वो क्या है? UI square. That is nothing but your square residuals. So what you are saying that instead of assuming the variance of UI to be depending on one of the explanatory variables in the model, instead of doing that, what we do is we run the normal regression, we obtain the square residuals, then we again run a regression of these logarithm values of squared residuals against the explanatory variables. You get the fitted values from this regression, and since you had applied logarithm to the squared residuals, that's why you again apply exponential, so that you convert it back in the same term. So that weight will be reciprocal of this exponential values of the fitted values from this regression.
Yes, sir.
Is this clear?
Yes,
So
understand.
ये जो स्टेप है जो आप रिग्रेशन रन किया, फिर आपने ये f is exponential values of this fitted values of the regression. So जो मेरा weight है, weight will be, that is weights which I'll use in order to remove the presence of heteroscedastic error term. So that weight will be 1 upon the exponential values of the fitted values from this regression.
All right, sir.
चलेगा ये बात?
Yes, sir.
So मतलब this entire step was necessary so that जो WLS, that is a method of weighted least square है, उसमें weights हम कैसे decide करें. So अभी उसके पहले is the weight that we assume that the error variance is proportional to the squared values of one of the explanatory variables. That weight did not work. That is, even after applying that weight through the weighted least square method, we could not remove the presence of heteroscedastic error term.
So now we are using a different weight to understand if that does a better job.
Correct. So this method is called as generalized least square method of assigning weights.
All right, sir.
ठीक है? So जो WLS है, it is just a special case of generalized least square. So WLS के केस में आप weights जो assume करते हो, so instead of assuming that weight, you decide the weight by running the regression of squared residuals on the explanatory variables. In this case, you need not assume any sort of relationship of variance with the other regressors in the model.
ठीक है सर.
ठीक है? और भी इसके बहुत सारे वेरिएंट है. In that case, you assign weights to be the fitted values of the original regression. Simple. So what you say is that your error terms are proportional to the fitted values of the regression. उसके हिसाब से भी आप weight decide करते हो. If that works, well and good. If that does not work, this is one of the methods of assigning weight which will more or less work all the time.
Sir.
हाँ जी.
So why have you taken exponential for the fitted values?
Because you took logarithm of residual r squared here. So in order to convert it back, we take the exponential values of the fitted r squared.
Okay, got it.
ठीक है? Neil, is this clear what we did?
Yes, sir. Also, sir, our studio is saying that the instead of weight, we should write weights.
Uh, I
Should we
think
should we
it
write
should
weights or
work.
weight? All
I
right,
think
sir.
it works. I don't think it's an issue. As far as
Okay,
my
sir.
our studio is concerned, it shall. All
Okay, sir.
right.
No,
Yeah.
no issues.
Okay. So let me just take one more topic before we wind up. So I'll just use again this. Just try using this formula in the previous data set. I'm really sorry. I don't know why it does not work there, but I'll check it again. So as far as heteroscedastic error terms are concerned, let me just recap what we have discussed so far. The test that we use in the R is generally Bruce-Pagan test. उससे आप detect करते हो, and if you are just concerned about running a test of significance which is valid asymptotically, then you only calculate White's heteroscedastic consistent standard error. वो जो स्टैंडर्ड एरर है आपको वो विदाउट अज्यूमिंग होमोस्केडास्टिक एरर टर्म वर्क करेगा. सो जो आपका यूजुअल टेस्ट ऑफ सिग्निफिकेंस है दैट विल ऑलवेज बी वैलिड. Now, if you are concerned about small sample cases, that you must go about removing the problem of heteroscedasticity. So basically, बहुत बार क्या करते हैं? We try to transform the variables. One of the major transformation is your log, taking log. The other ways are what is called as the method of weighted least square. So weighted least square method runs on the assumption that जो आपका error variance है, it is proportional on some values from the regression model, and that's how you assign weights to different error observations. Many times, this weight assignment, which depends on the assumption that you have undertaken, need not work. So a general method of assigning weights is you run the WLS as it is, obtain the squared values of those residuals, then run a regression of log of squared residuals on the explanatory variables which are used in the original model. Get the fitted values from this regression. Your weight will be reciprocal of exponentiated value of this fitted values. Apply those weights and then run again the BP test to check whether you have solved the problem of heteroscedastic error terms or not. Is this clear?
Sir,
Haji.
as this process always works like
This method of generalized least square will work more often than not.
Sir, here the PP test value has changed, but it's very low, so it's all right? Like it's 0.5, 0.05.
I think it is 6% here. So your evidence of null hypothesis will not be rejected at 5% level of 6%.
Yeah. Like it's a very less value. That's what I'm saying. Like 5% से थोड़ा ज़्यादा है,
Yeah. So if your level of significance is 5%, that is, if your null hypothesis is, there is no evidence of heteroscedasticity, your null hypothesis will not be rejected. So there is no evidence of heteroscedasticity. That's what you can conclude. Okay?
Sir, we have been saying that the variances of error terms increase when we plot them against the explanatory variables, any one explanatory variable.
Correct.
So how do we understand that whether it's increasing or decreasing?
Come again, variance of?
Variance of the error terms. We are saying that they are increasing and we are plotting them against the explanatory variables, the predictors. Any one of the predictors, right? And then how do we understand that whether the pattern is increasing or is it decreasing? How do you understand the nature of the pattern?
You see, variance आप कैसे calculate करते हो भूषण?
How
do you calculate variance?
You take the deviations from the mean and square root them,
Right. So you take the mean of residuals. जितना ज़्यादा observation will keep on going far away from the residual mean of the residuals. It means your variability is increasing.
Yeah. Okay.
So and negative positive values do not matter because ultimately you're squaring that difference.
Yes, sir.
है ना? So अगर आपका with increasing x, your the all the respective observations, error observations, if they lie farther away from the mean, it means your variability increases. That's why if you see a pattern somehow, some regular sort of pattern, when you plot the residuals or square value of residuals against these explanatory variables, then you are sure that now the variability increases of these residuals. Because your assumption of homoscedasticity is the variance of UI conditioned on the data matrix is constant, right?
Yes, sir.
है ना? So अगर वो x के साथ चेंज कर रहा है, it means अगर आपका जो एरर ऑब्जर्वेशन है, let's say x1 के लिए एरर ऑब्जर्वेशन थोड़ा मीन के नजदीक है, x2 के लिए एरर ऑब्जर्वेशन थोड़ा बढ़ा, x10 के लिए एरर ऑब्जर्वेशन is very far away from the mean value. It means your error variances are not constant for across each of the observations. That's how it is to be seen logically.
Yes, sir.
है ना?
What?
ठीक है?
Thank you.
All right. Do you have any other class or what, Abhi? Or can I extend this session?
Sir, our micro class is there.
So we have class, financial derivatives.
We have class right now, sir.
You have micro class right now?
General economics doesn't.
Acha, okay. No issue. So I'll wind up here. When are you guys free, at least in this week, for 4 hours or 6 hours? Are you guys free on Thursday?
So Wednesday and Friday we actually have one class, but
Wednesday we have one class at 5:30 to 7:30.
And
Economics.
Wednesday you're free.
Weekends we have business analytics, right?
Okay, so can you just coordinate with financial guys and have a class tomorrow if possible?
So tomorrow we have financial derivatives from 11:30 to 1:30.
No issue. Can we meet in the morning or late afternoon? It will work for me. Just give me 2.5 hours after. अगर शाम में भी करते हो, let's say 6:30. If you guys are ready, I'll have a lecture from 6:30 to 8:30. 6:30.
We'll be free in 9:30 to 11:30 time period.
Both the classes?
So financial eco.
It does not work that way. No, I have to coordinate for both the classes. So एक बार just who is the CR? Is the CR here? Any of the class? No, all right. So Sharanya, can you coordinate with both the CRs and let me know for the timings tomorrow? I'll take lecture tomorrow, no matter what. So